An object from beyond our sun barreled through the inner solar system on October 19, 2017, moving so fast it couldn't possibly have come from here. Astronomers named it Oumuamua, messenger from afar, and soon realized its brightness was flipping tenfold every 8 hours, hinting at a shape unlike any natural body we've ever seen. Oumuamua initial detection. A cosmic intruder just crashed our solar system's private party, and it came from another star. On October 19, 2017, astronomer Robert Warwick was scanning telescope data at the University of Hawaii when he spotted something that shouldn't exist, a fast-moving object that didn't belong to our neighborhood. The Pan-STARRS 1 telescope had captured humanity's first glimpse of an interstellar visitor, something that had traveled for millions of years through the void between stars just to reach us. What made this discovery so extraordinary wasn't just the object itself but the incredible timing. Scientists estimate that only one interstellar object passes through our solar system every few years, and most are just too small or too fast to detect. Scientists quickly realized this wasn't space junk or a rogue asteroid from our own system. The trajectory was all wrong, the speed was incredible, and the direction it came from pointed to deep space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, because it truly was our first confirmed messenger from another star system. The discovery process itself was remarkable. Warwick initially thought it might be an error in the data until he tracked the object across multiple images. Within days of discovery, telescopes around the world were frantically tracking this mysterious visitor as it raced through our solar system at 26 kilometers per second. The Minor Planet Center in Cambridge immediately issued alerts to observatories worldwide, triggering an unprecedented international collaboration. The object was already past its closest approach to the sun and heading back into interstellar space, giving scientists only a brief window to study it before it disappeared forever into the cosmic dark. What they found would challenge everything we thought we knew about space rocks, comets, and the possibility that we might not be alone in the universe. This cosmic messenger was about to rewrite the textbooks and spark debates that continue today. Classification challenges. Scientists love putting things in neat categories, but Oumuamua refused to play by the rules and turned astronomical classification into chaos. Initially classified as Comet C/2017 U1 on October 25, 2017, researchers expected to see the classic signs: a glowing tail, a fuzzy coma of gas and dust as ice sublimated near the sun. Comets are essentially dirty snowballs that light up beautifully as they approach our star, creating spectacular displays that have inspired humans for millennia. But Oumuamua was having none of it. No tail, no coma, no visible outgassing whatsoever, even though it had passed closer to the sun than Mercury's orbit. This was like expecting a snowball to melt in a furnace and finding it completely unchanged. Confused astronomers quickly reclassified it as Asteroid A/2017 U1, but that didn't feel right either. Traditional asteroids are rocky or metallic chunks left over from planetary formation, and they follow predictable patterns based on billions of years of observation. But Oumuamua's behavior was inconsistent with known asteroid properties. Its rotation rate, brightness variations, and movement patterns all suggested something fundamentally different. By November 2017, the International Astronomical Union faced an unprecedented problem and created an entirely new classification system just for Oumuamua, designating it 1I/2017 U1, the I standing for interstellar. This was the first time in astronomical history that a completely new category had to be invented for a single object, highlighting just how unprepared science was for visitors from other star systems. The classification headache revealed something profound. Our understanding of cosmic objects was based entirely on things that originated in our solar system, shaped by our sun's gravity and radiation over 4.6 billion years. Oumuamua was playing by different rules written in another star system billions of years ago under completely different conditions. Its refusal to fit into existing categories was the first hint that this visitor was unlike anything we'd ever encountered. And scientists began to realize they weren't just looking at a space rock, they were examining an alien artifact from deep space. Trajectory analysis. Tracking Oumuamua's path through space was like following breadcrumbs back to another world, and the story it told was absolutely mind-blowing. Astronomers used precise measurements from observatories worldwide, including the Very Large Telescope in Chile and the Gemini Observatory in Hawaii, to reconstruct its journey with incredible accuracy. What they found was a cosmic wanderer that had been drifting through interstellar space for millions of years before accidentally stumbling into our solar system like a lost traveler finding civilization. Dr. Marco Micheli and his team at the European Space Agency traced its origin to the general direction of the constellation Lyra, specifically toward the star Vega, one of the brightest stars in our night sky. But here's the incredible part. Even if it came directly from Vega, it would have taken 600,000 years to make the journey, meaning this object began its voyage when early humans were just learning to control fire. The trajectory analysis revealed that Oumuamua wasn't bound to any particular star system. It was a true galactic wanderer that had been drifting through the local standard of rest, the average motion of stars in our galactic neighborhood. The object entered our solar system from above the plane where planets orbit, approaching at a steep 122-degree angle that no local object could achieve. This approach angle was like a cosmic signature proving its interstellar origin beyond any doubt. Its hyperbolic trajectory meant it was moving too fast to be captured by the sun's gravity. This was a true flyby mission with no possibility of return. The orbital calculations revealed Oumuamua came within 0.25 astronomical units of the Sun on September 9, 2017, closer than Mercury's orbit, experiencing temperatures of over 300 degrees Celsius before being flung back toward interstellar space by gravitational slingshot effects. By the time astronomers discovered it in October, it was already racing away at 44 kilometers per second relative to the Sun, fast enough to travel from Earth to the Moon in just over 2 hours. The trajectory analysis proved beyond doubt that this was our first confirmed visitor from another star system, a cosmic time capsule that had witnessed the birth and death of distant worlds, survived the radiation of interstellar space, and arrived at our doorstep carrying secrets from the galaxy beyond. Photometry and shape analysis. So, photometry and shape analysis showed that Oumuamua was doing something no space rock should do. It was flashing like a cosmic lighthouse. Photometric observations from multiple telescopes revealed that the object's brightness varied by an extraordinary factor of 10 every 7.3 hours as it tumbled through space. This dramatic brightness change suggested something unprecedented, an object so elongated that it was unlike anything in our solar system. Dr. Karen Meach from the University of Hawaii led the analysis, calculating that Oumuamua was at least 10 times longer than it was wide. Imagine a cosmic cigar, or maybe a football spinning end over end. Some models even suggested it could be more extreme, possibly a 20-to-1 length-to-width ratio. But Dr. Sergei Moschenko proposed an alternative. What if it wasn't cigar-shaped but pancake-shaped? A flat, disc-like object could also produce the same brightness variations. The tumbling period was unusual too. Most asteroids rotate much faster, but Oumuamua's leisurely spin suggested it might be held together by something other than typical rocky materials. The photometric data painted a picture of an object so bizarre that it challenged our understanding of how planetary formation works. No known process in our solar system creates objects with such extreme dimensions. This wasn't just unusual, it was honestly geometrically impossible, according to everything we knew about how gravity shapes space rocks. Oumuamua was, in a sense, rewriting the rules of cosmic architecture. Acceleration anomaly. And then, there was the acceleration anomaly. Oumuamua just broke physics, and scientists are still trying to figure out how. As telescopes tracked the object's movement away from the sun, something impossible happened. It started accelerating faster than gravity alone could explain. Dr. Marco Micheli's team at ESA first detected this non-gravitational acceleration in June 2018, analyzing data from the Hubble Space Telescope and ground-based observatories. The acceleration was tiny, only about 0.00005 meters per second squared, but it was real and measurable. For comparison, if you dropped a feather and it fell upward instead of down, that would be less surprising than what Oumuamua was doing. In our solar system, when objects accelerate away from the sun without gravitational explanation, it's usually because they're comets releasing gas and dust that creates a rocket-like thrust. But Oumuamua showed no signs of such outgassing. No tail, no coma, nothing visible that could explain the extra push. The acceleration was also pointing in exactly the right direction, directly away from the sun, which made it even more mysterious. Professional astronomers ran the calculations dozens of times, checked their instruments, and consulted with colleagues worldwide. The result was always the same. Oumuamua was being pushed by an invisible force. This single observation transformed a curious interstellar visitor into one of the most puzzling objects ever detected, launching 1,000 scientific theories and capturing the imagination of anyone who wondered if we might not be alone. Spitzer Observations. NASA brought out the big guns to solve the Oumuamua mystery, and what they found made everything more confusing. The Spitzer Space Telescope, with its incredibly sensitive infrared detectors, was humanity's best hope for detecting any invisible outgassing that might explain the object's mysterious acceleration. Dr. David Trilling from Northern Arizona University led the observations in November 2017, pointing Spitzer's instruments at Oumuamua as it raced away from the inner solar system. Infrared telescopes can detect heat signatures from sublimating ice and microscopic dust particles that are completely invisible to optical telescopes. If Oumuamua was secretly behaving like a comet, Spitzer would catch it red-handed. The results were published in the Astronomical Journal in 2018, and they were as puzzling as they were definitive. Nothing. Absolutely nothing. Spitzer's upper limits on dust and gas production were so strict that they ruled out traditional cometary activity by orders of magnitude. If Oumuamua was releasing material to create thrust, it was doing so at levels 10,000 times lower than typical comets. This wasn't just unusual, it was physically implausible. The Spitzer observations eliminated the most obvious explanation for the acceleration anomaly and forced scientists to consider more exotic possibilities. Either Oumuamua was made of materials that don't exist in our solar system, or it was being pushed by forces that we don't understand, or, well, it wasn't natural at all. Artificial origin hypothesis. So here's the thing. Harvard astronomer Dr. Avi Loeb dropped a scientific bombshell that made headlines worldwide and honestly divided the astronomy community. Back in October 2018, Loeb and his postdoc Dr. Shmuel Bialy published a paper suggesting that Oumuamua might not be a natural object at all, it could actually be artificial technology created by an alien civilization. Their hypothesis, which was published in the Astrophysical Journal Letters, proposed that Oumuamua was a light sail, an ultra-thin sheet of material designed to be pushed by radiation pressure from stars. This idea would explain both its unusual shape and the mysterious acceleration, without needing any detectable outgassing. And, light sails are real technology that humans are developing for interstellar missions, so the physics behind it was actually sound. Loeb calculated that an object only millimeters thick, but hundreds of meters wide could behave exactly like Oumuamua, accelerating away from the sun as starlight pushed against its surface. The paper, as you might imagine, sparked fierce debate in the scientific community. Critics argued that invoking alien technology violated Occam's razor, the principle that simpler explanations are usually correct. But Loeb countered that the scientific method requires considering all possibilities, even the uncomfortable ones. His 2021 book, Extraterrestrial, further developed this hypothesis, arguing that scientists' reluctance to consider artificial origins was more about sociology than science. Whether he's right or wrong, Loeb's proposal really forced astronomers to think outside conventional boundaries, and consider that our first interstellar visitor might have been our first contact with alien engineering. Dark comet theory. So scientists found a kind of middle ground between the idea of a normal space rock and the more far-out theory of an alien spacecraft, and it's called the dark comet hypothesis. Dr. Daryl Seligman from the University of Chicago, along with his colleagues, actually proposed back in 2019 that Oumuamua belonged to a previously unknown class of objects that behave a lot like comets, but basically remain invisible to us. These so-called dark comets would have just enough ice to create the non-gravitational acceleration we saw, through a process called sublimation, but at levels so low that our instruments just couldn't pick up the outgassing. The theory suggested that Oumuamua was made of materials that had been altered by billions of years of exposure to cosmic radiation out there in interstellar space. This kind of space weathering could create a dark, carbon-rich crust that would hide any ice underneath and make the object look a lot more like an asteroid than a comet. Computer simulations even showed that tiny amounts of sublimating hydrogen gas, basically invisible to most telescopes, could produce exactly the kind of acceleration that was observed. The dark comet model explained Oumuamua's behavior without needing to invoke exotic physics, or, alien intervention. It also suggested that interstellar space might actually be filled with these mysterious objects, failed comets, planetary fragments, or debris from destroyed worlds that have been wandering between the stars for eons. The hypothesis gained even more credibility when astronomers began finding similar objects right here in our own solar system. Small bodies with mysterious accelerations but no visible outgassing. So, Oumuamua might not be unique after all. Maybe it's just the first representative of a hidden population of dark wanderers that populate the galaxy. Dark comet classification. The mystery of Oumuamua got even more interesting when astronomers started spotting similar objects basically hiding in plain sight within our own solar system. In 2023, Dr. Daryl Seligman and his team published some pretty groundbreaking research identifying 7 near-Earth objects that showed the same puzzling behavior: non-gravitational acceleration without any visible outgassing. These objects, now officially classified as dark comets, provided the missing link in understanding Oumuamua's true nature. The research published in the journal Icarus actually revealed 2 distinct populations of dark comets in our solar system. Outer dark comets like 2003 RM and 2010 VK118 follow eccentric orbits similar to traditional comets but show no visible activity. Inner dark comets, like 2007 VA85, orbit closer to the Sun and tend to be smaller, which suggests different formation mechanisms or evolutionary histories. This discovery was honestly revolutionary because it meant dark comets weren't just rare interstellar oddities. They were a previously unrecognized population that had been masquerading as asteroids for decades. The new classification system distinguished them from regular comets and asteroids based on their orbital dynamics and the lack of any detectable coma or tail, despite clear evidence of non-gravitational forces at work. Finding dark comets in our own solar system strongly supported the idea that Oumuamua belonged to this category. It suggested that these kinds of objects might actually be common throughout the galaxy. Invisible wanderers moving between star systems, maybe even carrying ice and organic materials that could seed life on distant worlds. The dark comet classification really transformed Oumuamua from a unique anomaly into the first confirmed member of a whole cosmic population we never even knew existed. Scientific debate. 5 years after Oumuamua's flyby, the scientific community is still, fascinatingly divided. And that's actually how science should work. Multiple competing theories keep battling it out in peer-reviewed journals, with each one having some pretty compelling evidence and passionate supporters. The mainstream scientific consensus has gradually shifted toward the dark comet explanation, with researchers like Dr. Jennifer Bergner from the University of California, Berkeley publishing detailed models in 2023, showing how hydrogen outgassing could explain every observed characteristic of Oumuamua. Meanwhile, Dr. Avi Loeb continues to push for the artificial origin hypothesis, launching the Galileo project to search for similar objects and develop new detection methods for potential techno-signatures. Some conservative astronomers prefer explanations involving exotic but natural processes. Maybe Oumuamua was a fragment of a nitrogen iceberg from a Pluto-like world, as Dr. Alan Fitzsimmons proposed back in 2021. The debate has actually produced over 200 scientific papers since 2017, each one adding new pieces to the puzzle. What makes this controversy especially valuable is that it's driving innovation in observational astronomy and interstellar object detection. Projects like the Vera Rubin Observatory, which is set to begin operations in 2024, will discover hundreds of interstellar visitors in the coming decade. The European Space Agency's proposed Comet interceptor mission could even rendezvous with the next Oumuamua-like object. No matter which theory ends up being correct, Oumuamua has fundamentally changed our perspective on the solar system's place in the galaxy, and reminded us that the universe still holds some pretty profound mysteries waiting to be solved. Alright, that's a wrap on Oumuamua's mind-bending mystery. This interstellar visitor really challenged everything we thought we knew about space objects and honestly left us with more questions than answers. Was it a dark comet, alien technology, or something else entirely? The truth is still out there, just waiting to be discovered. So, what do you think Oumuamua really was? Drop your theories in the comments below. I actually read every single one. And hey, if you're hungry for more cosmic mysteries and space facts that'll totally blow your mind, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries. The universe is full of secrets, and we're just getting started uncovering them together here at Space Facts.